I, again, am grateful that you took the time out of your schedule to join us today. This is the second in our two-part series on sustainable aviation fuel. We had a speaker, Keith Sawyer, last week from AvFuel, who joined us and gave us basically an introductory course into what sustainable aviation fuel is. And today we're going to be talking with the OEMs from around the world on the use of sustainable aviation fuels in their aircraft. As I mentioned, we have an exceptional group of panelists today. We'll start with Jim Viola. I don't have a slide for him, but we are going to be getting a recording for Bruno Evans, who is the Chief Executive Officer for Airbus. He will be followed by Safran Tomé, who is the Executive Vice President for Engineering and Chief Technical Officer with Airbus Helicopters. We have a video from Michael Thacker, Executive Vice President for Innovation and Commercial Business with Bell. He'll be followed by a live presentation from Doug May, who I think has one of the coolest titles I've seen, Vice President of Flight. We'll have another video from Frank Sauda, who is the Chief Executive Officer of Safran. And then we have a live presentation from Jean-Baptiste Charin, who is the Deputy Program Lead for Research and Technologies for Sustainable Aviation Fuels with Safran. Our webinars are interactive. If this is the first one you joined, we do encourage you to ask questions. We will get to the questions at the very end of the webinar. To submit a question, please use the question module that is part of the Zoom package. We do follow the chats, but we can't keep track of all of them necessarily. And so we definitely pay attention to the question module. So either at the bottom of your screen, on the side of your screen, wherever that module might be within Zoom, please use that to submit your questions. Our webinars are recorded. If you missed something or if you want to share this, we will try to make the link available as quickly as possible. That's usually within about 24 hours, sometimes depending on the rendering time. It can take over the weekend, and we'll try to get that posted just as quickly as possible. You'll be able to find that on the rotor.org website, rotor.org/webinars, and it'll be on our HAI social media channels, and we'll be sharing this with the participants as well. So now please allow me to introduce Jim Viola, the President and CEO of HAI.
All right, thanks, Dan. Glad to be able to kick this off again today, and welcome to everyone to the Sustainable Aviation Fuel, or you'll hear us referred to many times today as SAF. And it's a webinar series. As many of you know, we hosted the first webinar in this series was last week, and we heard from a very informative presentation from Keith Sawyer from Aviation Fuel. And it was about understanding what SAF is, how it is made, how the supply chain works, and what challenges and also opportunities exist for making SAF more readily available for all of you out there in the industry. It was very helpful, and it helped set the foundation for this series. Today, we're going to actually hear from the OEM's perspective on SAF. What are the groundbreaking sustainability initiatives taking place globally in the rotor industry? And our guests today have been leading the way with their perspective companies. You're going to hear all about these efforts and why they are making these investments. Sustainability is very much in focus everywhere around the world by all the policymakers, not just the United States, but international, as part of the US White House's goal of net zero emissions by 2050. And earlier this month, the US President announced the launch of a new Sustainability Aviation Fuel Grand Challenge, which aims to increase the production capacity by 3 billion gallons by 2030. So on Capitol Hill, as we sit, Dan and I are down in the headquarters building, there's SAF blenders tax credit is being considered. All these little things to try to help us move forward or where we need to go with the sustainability fuel. So the commitments from all segments of aviation industry are being made to reduce emissions. The EU has bold plans to reduce emissions 55% by 2030. And as the leading association for vertical flight, we have an obligation to you, our members, to encourage progress and to promote safety along that way. So HAI supports increasing the supply and usage of SAF. And is honored to have our guest here today to talk about what they're doing and how they are helping the industry move forward. I appreciate their willingness to be here and answer questions and share their perspective with us. And with that, as Dan had said, some of them aren't here, but we reached out and we've got some videos as well. So hopefully they'll be well presented, and then we'll be open for questions. So we'll get started. A brief introduction. I think Dan had mentioned Bruno Even is the CEO of Airbus Helicopters as of April 2018. He joined the company from Safran, where he held various management positions at the helicopter engines and the electronic defense business. In addition to his position as CEO, Mr. Even also serves as a member of the Airbus Executive Committee. After that, we have Stefan Thom of the Executive Vice President of Engineering, as well as a Chief Technical Officer at Airbus Helicopter Division since April 2019. Prior to assuming that role, he led the new digital business models and services at Airbus Defence and Space starting in 2018. He also heads the Manufacturing Engineering Department as a member of the Airbus leadership team. We have Michael Tacker. He is the Executive Vice President of Innovation and Commercial Businesses at Bell Flight as of June 2020. He also serves as a member of Bell's executive leadership team. In February 27, 2017, Mr. Tacker was named the Executive Vice President, Technology and Innovation, and previously served as the Senior Vice President of Engineering at Textron Aviation. We also have Doug May. He is the Vice President of Flight at Bell Flight, appointed in November 2019. He has enjoyed a long career in aviation and previously served in various positions at Textron Aviation. Mr. May is an Associate Fellow at the Society of Experimental Test Pilots, and he holds an ATP rating airline transport pilot with over 5,500 experimental flight test hours and maintains his rotorcraft pilot license. We have Frank Sadu, is the Chief Executive Officer of Safran Helicopter Engines, and as of April 2018, looks like a lot of people use April for taking on new positions. He joined Safran in 2011 as the Deputy to the group's Executive Vice President for Strategy and Development. Mrs. Sudu has since held several positions at the company, including CEO of the Safran Transmission Systems and Vice President of Support and Services. And then we have Jean-Baptiste Jarin is the Deputy Program Manager of Research and Technologies at Safran Helicopter Engines, where he has overseen sustainable aviation fuels since October 2020. He joined Safran in 1999 and held various positions within the power units and helicopter engines since 2005. So thank you all for participating via live as well as the recordings we have. And Dan, let's get this going. Thank you.
Okay, thank you, Jim. I appreciate that. We'll go ahead and get things rolling right now. I'm going to turn my camera back off, and what we're going to do is we're going to watch the first video from Bruno Evans with Airbus.
Thank you, Jim. Airbus is a long-time member of the association, and I'm pleased to share this message with your members for HI's webinar on sustainable aviation fuel. Let me introduce myself. I'm Bruno Even, CEO of Airbus Helicopters. At Airbus Helicopters, we have been pioneering innovations for decades. Innovations that have increased safety, reduced sound levels, and reduced CO2 emissions already by 50% since the beginning of vertical flight. However, it is plain to see that climate change is the greatest challenge of our generation. At Airbus, we understand that society expects us to rise to this challenge. This is why we are taking the lead on an industry-wide decarbonization movement that aims to usher in a new era of climate-neutral aviation and sustainable space. Our purpose is to pioneer sustainable aerospace for a safe and united world. This is true for all of the divisions of the company. Helicopters and the missions they perform are already sustainable. Helicopters perform fundamental missions: disaster relief, search and rescue, firefighting, to name a few. They reach people and areas that are otherwise inaccessible. I'm sure we can all agree that they make a difference. Helicopters account for less than 1% of the global CO2 emissions, but there are still ways that we can reduce that figure. It is through the adaptation and renewal of our fleet that we'll be able to rise up to the challenge of decarbonization and improve the environmental performance of our rotorcraft. We are committed to reducing that environmental footprint to get closer to the end goal of net zero CO2 emissions. There are many roads that can help us reach this target. We are confident that by exploring each of them, we'll find the most efficient lever to achieve sustainable transport and build the helicopter fleets of tomorrow. Innovation is a pivotal element that will help us move toward decarbonized operations. In line with our commitment to continuous improvement, we have already started applying several innovations to our current range of products to change the way we make it fly today. One of the prime examples of that is the H160. Its Arano engine reduced fuel consumption by 15%. On top of the innovation that we introduced to our product range, one of the first steps we took to drive positive change in the industry in the short term is the use of sustainable aviation fuel, or SAF. SAF is an alternative fuel sourced from waste material that is combined with jet fuel and is able to reduce the level of carbon dioxide emitted during a flight. Several aircraft in our fleet, like the H145, the H175, and the H225, have recently completed flight tests with SAF, and others will soon be able to do so, as our entire range is certified to fly with a blend of as much as 50% SAF. We also created an Airbus Helicopter SAF user group, which opened a collaborative discussion to tackle the challenges around biofuels with other key players in the industry, in order to generalize the use of SAF in the aviation community. We held the digital kickoff meeting on the 16th of July, and around 43 companies, ranging from engine OEMs, fuel system suppliers, energy companies, and a considerable number of helicopter operators joined in. This really reinforces the necessity to work together towards implementing sustainable aviation fuels in our rotary wing community. It is our collective responsibility to contribute towards zero emissions, and SAF is a major contributor to reaching that goal. As of today, 40% of net CO2 emissions could be avoided by using SAF blends. The Airbus Helicopter SAF user group intends to gather the various industry stakeholders in order to accelerate this change and to encourage collaboration in order to build up the SAF supply and to ensure the exchange of information and experiences. But our roadmap does not stop there. Using both thermal and electrical energy at the same time also allows for reduction of CO2 emissions. By optimizing energy consumption, hybridation helps us adapt to the required propulsion level during each phase of the flight. Thanks to Airbus Flight Lab, we'll also be able to add a technobrick derived from hybridization to our fleet, the engine backup system that provides electrical power to the aircraft in case of engine failure. That is why we are currently working on finding the most efficient mix between these two sources of energy as a way to reach a first milestone toward fully electric propulsion. Indeed, we are exploring the numerous advantages of full electric thanks to City Airbus. The demonstrator benefits from a wide range of innovative technologies that makes it a leader on the path toward tomorrow's way to connect people. With City Airbus, we are striving to build the means of transportation that will revolutionize the organization of cities around the world towards safer, faster, quieter, and more reliable urban mobility. It is a stepping stone for Airbus' commitment to sustainable aviation. We should not forget that the journey toward clean aviation is also about reducing the impact of our industrial activity on the environment while maintaining the highest safety and quality standards. In order to reduce our CO2 emissions, we are working on multiple pillars that will all help us improve the integration of environmental criteria into our daily business processes. In closing, I would like to take this opportunity to call on all HI members to join the Airbus Helicopter Sustainable Aviation Fuel user group to pioneer sustainable aerospace with us.
Okay, that was a very interesting and moving segment on how Airbus is obviously making a very strong commitment to reducing carbon emissions into the atmosphere, both through SAF and electric propulsion. Now I'd like to introduce Safran Tomé to come on and make his presentation on how the aircraft are working with the SAF fuels. Thank you, Safran. Thank you for joining us today.
Thank you very much, Dan. It is my great pleasure. And thanks for having me and also having us on this event, which, if I may say this, is not only a great source of information to all of us, but also a continuous inspiration. So we are all looking the videos every now and then on the page, and I use the opportunity to say thank you very much to HAI for this service to the community, which is really important. Now, I will try to build up on what Bruno has been explaining and give it a little bit more illustration and color here and there. And I would start doing so, and here in the circle, I am not ashamed to confess that I'm, a helicopter enthusiast. And as such, I want to start reminding us something which we are all aware of, but we easily forget it on our day-to-day business with the helicopters. Helicopters are really a unique and if we think about it, a very specific product for essential missions. If we think about, you just mentioned firefighting a minute ago in the States, or all the rescue missions being done in the counties all across the States and all across the globe. Helicopters get where no other product can get to, and they fulfill missions for society and for humanity, which no other product can fulfill alike. And this is a great formula to have. And sustainability is not only about environmental friendliness. In the word, there is the notion of sustaining, and that means to last over time. So we want this service to last over time. We want to have it sustainable. And I believe this is a common ground for all of us of the community. And it is really an effort the community needs to be undertaking. Now, one facet of being sustainable for the future is to be also more environmental friendly, to reduce the emissions, carbon, but not only, noise, but not only. And I want to take the turn here. So that it is worthwhile to work and to strive for keeping helicopter missions at hand for society and humanity. This is what we are deeply convinced of. And I believe, and I hope this is shared by many of you. Now, once we suppose this, then the question, why is SAF, sustainable aviation fuel, so crucial? And here I just want to bring a few elements which are not very often discussed like this. And I wanted simply to show it. We see here, helicopters do particular missions, but they also have a very particular, we can also say, high power need. Hovering the mass in the air is not exactly what physics, like to happen. So there's quite an effort to it to make it happen. And we need to acknowledge this, and we need to confess it. You see that the power curve of a typical helicopter, a 6 tons helicopter, and you see on the lower part of the page, you see how this power can be provided. So conventional fuel, we all know it, and there's no difference to the sustainable fuel. So you see the same figures there, same mass, same volume. And the point I want to make here is, there's a buzz around the world, especially when it comes to other configurations, about hydrogen, for example, or also the electric flying. And even we ourselves, for particular missions, we consider it and we mention it. But really, when we think of the configuration of a helicopter, we really put sustainable aviation fuels first, just for the reasoning you see here on the page. We cannot afford the mass and the volume of the battery. We can also not afford the complexity and the volume of the hydrogen. So we are more than happy and grateful. And this is one driving force of several why really the sustainable aviation fuel is on top of the talk, but also on top of the actions of many, as Jim, you rightly mentioned in your introduction. So there's a reasoning there, clearly. Next point I want to tell, at Helicopters, we are not only focusing on, let's say, getting sustainable aviation fuel into our helicopters as fast as we can. We should do basics first. And this is one other element I also wanted to bring to the community. There is really still a great potential on reducing the energy amount which is needed. You see here a few elements which we are working on to reduce the amount of energy, whatever the energy source in the end is, whether it is sustainable fuel, aviation fuel or others. The first thing we are striving for is reduce. And this is classical engineering. There's also another message in it. We really shall not forget the basics of our products, having them lightweight, having them efficient. And here a big shout out also to our dear engine OEMs. We are joining forces on this, on the improvement of the efficiency of the engines. Then also innovations like eco mode, which is on 2-engine aircrafts, an on and off switching of the second engine when you don't need it. Then the idea of hybridization, boosting a gas turbine engine with some electrical driven auxiliary power units, I would say. And last but not least, for particular missions inside cities where you may not have local emissions, there, yes, we also go on the path of full electrification. And finally, you have heard that Airbus for the planes is also going on the hydrogen path. And we are with Helicopters attentively following this path on the what I would call on the commercial aviation. And all this is accompanied, in our view, by the immediate use of sustainable aviation fuel, which we do for our own internal operations. And here I want to, let's say, clarify to us something which in my view was not so clear last week in the sustainable aviation fuel webinar. There are, in our view, two notions of sustainable aviation fuel. There's the blended one, and this is available for everybody already as per today. You can fill up your helicopters up to 50% with sustainable aviation fuel, and you can still fly it because it is a Jet A1 fuel, this blended fuel. So first, there's the blended SAF. And second, and this is for us a difference, we speak about the 100% SAF. So there is no blending there anymore. This is really 100% sustainable aviation fuel, which is not yet standardized. Here Airbus is working with the American Society for Test and Materials, for the ASTM, like Boeing and General Electric and many others are doing. But the point I want to make is there are two sustainable aviation fuels, the blended one and the 100% one. And we are working on both. The blended one we took into operation several months ago. And by this, you immediately reduce, if you fill up your helicopter with 50%, you reduce the carbon emission by 40% overall. Why 40? Because the SAF reduces by 80%, it's proportional, and if it is half, then it makes 40%. And that already at Airbus Helicopters makes a significant lower carbon emission footprint during this year. As we speak, our operations are in sustainable aviation fuel. You see here on this page the notion of pictures of these operations. You also see here the yellow one. It is a customer helicopter, and this is the other element I want to bring. It is not only an OEM push, the sustainable aviation fuel. And maybe some of you listening are operators and customers, and you might confirm, we clearly at Airbus Helicopters also see a customer pull, so to say. Clearly, operators, customers, they are citizens as we all are. They have children, we are all concerned about the future of our planet. And they keep demanding, guys, what do you do on the products? Can we fly the SAF? How can we fly it? What are the constraints? and how can we move this happen? And some customers make product choices based on the feasibility or not to operate using sustainable aviation fuels. Here you see a few more future-oriented elements, and I was smiling because last week Keith was also using this SAF life cycle. So I believe this will become a standard in the coming weeks. This icon there, but a few more statements. So we are at Airbus Helicopters going for the 100% SAF by the end of this decade, and we are pushing this with the international standardization, but also with our products. You will ask, where's the impact on the products if you have 100% SAF? There are two possible consequences there. First, it's on the fuel gauging, and second, it may be on seals and rubber and basically the fuel bladders, where it is still to be defined whether it has what impact the SAF has on the material characteristics of these, what I would call rubber elements. We support by this also the World Economic Forum Clean Sky target, which is by 2030, Jim, you mentioned it, to have at minimum 10% SAF operations. We are also contributing to a new, let's say, sustainable aviation fuel, which is power to liquid. You basically take clean electrical power, you take carbon, you take hydrogen, and you synthesize a fuel out of this. This is what is called power to liquids. I mentioned already, we have our industrial flights with SAF, and we launched the user group where we really called around the globe all stakeholders to come with us on this exchange platform to keep addressing issues and to keep moving forward all together. That's somehow at a glance what I wanted to say. This last page here is just another detail on how we see the community, and I'm very glad to be not alone today, but also to having another colleague, another OEM colleague with us, and also one engine OEM, because really this is a joint effort. And I don't see how we are competing on this. I consider this really a community objective to be sustainable with helicopter operations. And there are other stakeholders like authorities. I mentioned the customers, but also, of course, airports and also energy suppliers. I can tell you we are having intense discussions about the supply and the availability and also the grading height of the sustainable aviation fuels. As per today, the availability is an issue still, but we are of the opinion, let's create the demand and then the supply will follow, not the other way around. We do not like the idea that the demand is waiting the availability of the product. Last comment then, and then I give back to you. Anybody who is further interested, ask questions later, but also join us if you will, and you see the email there, join us on this user group, because there we want to push forward as a community. Thank you very much, and back to you then.
Dan, you're muted.
In our ever-evolving industry that connects global markets and delivers breakthrough technology advancements, we have now reached an inflection point where we must start a new journey, the decarbonization of aviation. I'm Michael Thacker, Executive Vice President of Innovation and Commercial Business at Bell. Bell continues to lead the industry discussion on sustainability initiatives, starting with our implementation of sustainable aviation fuel. Early this year, we announced we would begin using sustainable aviation fuel in our Bell Training Academy and customer demonstration aircraft, a key milestone in our journey to pioneer and implement greener technology in all aspects of our operations. We partnered with AvFuel to establish a steady supply of the alternative fuel source to our facilities and became their first rotorcraft customer to use SAF. Today, our Bell Training Academy customers continue enriching their flight knowledge with our world-class instructors and products, while emitting up to 80% less carbon emissions. Safety is always a top priority for Bell. We continue to reiterate that this fuel requires no modification to the aircraft or any additional pre- and post-flight procedures. Customers appreciate the seamless transition, and we continue to educate and advocate for its benefits to a global audience of rotorcraft operators. The drive for greener technology at Bell does not end with this alternative fuel initiative. We are supporting Textron's Achieve 2025 mission to reduce greenhouse gas emissions by 20%. Always innovating and enhancing our products, Bell's electrically distributed anti-torque demonstrator, known as EDAT, promises enhancements to safety and operating cost, as well as a reduction in noise. The technology was recently on display during an announcement from the Government of Canada to invest in Bell for the development of environmentally friendly aviation technology. Our work in autonomy has also resulted in the all-electric autonomous pod transport, a completely autonomous eVTOL platform that has flown with 110 pounds of goods over an 8-mile route. Every day, our engineers delve deeper into the world of electric propulsion and battery technology, carving new paths forward for greener energy systems to support the aircraft of today and of the future. But collaboration is critical if we're going to reach our full potential to improve safety and sustainability. Having a cleaner environment for our future is a shared industry goal and demands participation from all OEMs, customers, and innovators. Bell is proud to partner with each of you to lead this effort. Thank you to HAI for bringing together industry leaders to discuss more sustainable paths forward for our industry. It's our responsibility, now more than ever, to keep innovating, keep exploring, and keep pursuing better solutions for our customers, our products, and our planet. And I thank you for joining Bell on this journey towards a more sustainable future.
Okay, obviously I had myself muted and did not create the proper introduction. That was Michael Thacker, who is the Executive Vice President of Technology and Innovation for Bell, with that another very inspiring presentation, great video. So now I'd like to introduce Doug May, who is the Vice President of Flight at Bell, for his presentation.
Well, good afternoon, and thanks, Dan. And I just got to tell you, I'm glad that happens to somebody besides just me. So thanks for that. Well, thanks for allowing me to have a conversation with you today. I'm thrilled, really, to discuss sustainability, especially Bell's recent efforts to play our part in the decarbonization of aviation. As I think Keith mentioned multiple times last week in his presentation on SAF, the largest potential reduction in emissions, no doubtedly, will come from our usage of SAF. And I think it was mentioned just a moment ago that it really needs to be demand that drives supply, and Bell agrees very much with Airbus in that regard. So the message today really is that we all need to do our part in order to be able to continue to propagate the demand, and as I mentioned, that will drive supply. So at Bell, we realized that we have to play our part, and we have to play a critical role in upholding our commitment to green operations. And that's why in March of this year, Bell announced that it would begin incorporating sustainable aviation fuel, or SAF as everyone calls it, into the Bell Training Academy. It's roughly a training organization of just under 20 aircraft, but we also incorporated it into our customer demonstration aircraft so that we can show that on a real-time basis to our customers as they're interested in our product and as we move them forward. We're introducing it to people as we go. So we're the first rotorcraft customer to receive SAF from our partner. You heard Michael mention AvFuel Corporation. They have been supplying us with SAF since the March timeframe of this year, and they continue to make sure that we have a steady supply of SAF to our facilities. Obviously, SAF is a cleaner supply and source of fuel to power rotorcraft, and it decreases our environmental footprint, which is something that Bell is very, very interested in. So I think you've heard statistics around the carbon reduction and emission reductions that is associated with SAF. But obviously, Bell is partnering with Avfuel to use the Neste MySAF blend, and in its renewable, or rather, I should say, in its 100% renewable, sustainably sourced waste. Things like cooking oils and grease and rendered animal fats are really what make up the Neste blend. In its pure form, it can reduce carbon emissions and greenhouse emissions by up to 80% as compared to normal Jet A. And once blended, Avfuel anticipates that there's a 22 metric ton reduction in life cycle carbon emissions, essentially per truckload. At BTA, as we incorporated SAF into our operations, we really noted that that was a seamless transition. And we're getting a significant amount of customers who, as much as we talk about it, and as much as we're trying to continue to help propagate the message of SAF, quite frankly, haven't been introduced to it. So I would encourage all of us, kudos to those of you who are on the phone, who are being proactive and leaning forward and learning about SAF. I would encourage you to take the next step, and that is to talk to those who you know in industry as well. The real success of SAF and driving the demand for SAF is going to be that from all of us who talk to those who we know and encourage people to understand SAF, to do the research on it for themselves, to understand that there are no modifications required to their helicopters, and understand that it's a drop-in replacement every bit as good as the Jet A that they're accustomed to burning and have been for a long time. But in addition to SAF, there are a number of things that are in play at Bell, as well as at Textron, in other ways to help diminish our fuel consumption. So Dan, if you can go to the next slide for me, that'd be great. In 2020, as part of our Achieve 2025 initiative, you heard Michael talk about that just a little bit, Textron established a new set of 5-year sustainability goals. They were based in essentially 4 areas: greenhouse gas emissions, energy use, water use, and waste generation. And those goals were developed to create a company that will be more efficient in Textron as its use of natural resources is optimized, and it allows us to be better in the communities in which we operate. In 2020, Textron operations around the globe were able to complete literally 145 sustainability projects aimed in all 4 of those areas I just mentioned, with a net savings of over $2 million for the organization. But really more important than the money savings that can be had is really the sustainability effort and the desire for Textron to improve by increasing our energy efficiency and reducing our greenhouse gas emissions. Project savings resulted in essentially greenhouse gas emissions in a reduction, I should say, in greenhouse gas emissions by over 5,500 tons. And that's really just getting started. So we've watched other examples within the Textron business unit family, things like Textron Aviation in Wichita, leveraging green energy from energy centers powered by windmills to support their aircraft manufacturing operations. So they've made a commitment with Evergy Incorporated to draw from one of the local local centers for wind energy to essentially power all of their manufacturing going forward into the future. And with the implementation of SAF, if we go back to that for just a second, we're thrilled to support the larger corporate initiative and the Initiative 2025 that is in play at Textron today. In addition to that, we've had other milestones, and you heard Michael mention a few of them, and I'll go into just a little bit of more detail there. So Bell's electronically distributed anti-torque demonstrator, that we call that the EDAT, that promises enhancements to safety and operating costs, as well as a reduction in noise. So it's the first technology of its kind in the industry. The EDAT system is really composed, as you saw in the pictures, of 4 small fans within a tail rotor shroud in an offset 2x2 pattern. Each of those rotors contains 4 blades, which are powered by 4 separate motors, all independently controlled, with the electrical energy provided through generators driven by the turbine engines, effectively reducing noise, and then again, in addition to that, offering lower operational as well as maintenance costs compared to aircraft of today with conventional tail rotors. We unveiled it in February of 2020, but obviously have been flying that for some period of time before that. Also in 2020, it was recognized, or the EDAT was recognized by Popular Science as the winner of its Best of What's New award in the aerospace category. Technology, again, was mentioned by Michael, and it was recently on display during an announcement from the government of Canada to invest in Bell for the development of environmentally friendly aviation technology. That particular program is called the Aircraft for Digital and Green Mobility of Tomorrow. Bell is part of a consortium where we'll develop advanced propulsion systems to support future technology. Other participants in the collaboration will be CAE, Pratt & Whitney Canada, a number of small and medium enterprises and academic institutions. And the project will consist of exchanging, sharing, and leveraging information related to technologies developed individually by each company to make sure that that program stays on track and is a success. In addition to that, our work in autonomy has also resulted in what you can see in the lower left-hand picture as what we call the autonomous pod transport. It's a completely autonomous eVTOL platform, and it's been flown, or I should say it has flown with a payload of about 110 pounds over an 8-mile route. So if we go back to SAF just for a minute, incorporating that into our aircraft has been a massive step forward. We have seen nothing but upside with regard to our interactions with our customers, with our students at the Bell Training Academy. And really, that is, it's a huge step forward for us in leveraging sustainability, but it really is, it's a major portion of our sustainability initiatives. But I hope you've seen just a little bit of some of the other stuff that we've been working on. So my hope, and I really look forward to sharing with you even more sustainability milestones, because at Bell, we are committed across a number of platforms in moving our journey forward. So we will continue to develop greener technologies. SAF is a key player in that. I would encourage all of us to, as I mentioned, talk to our friends and our coworkers and move SAF forward. Bell certainly is doing that. But with that, I'll turn it back to Dan and say thank you.
Thank you, Doug. Gosh, I appreciate that presentation. Looks like some great things are going on at Bell, just like they are at Airbus. So we are pleased you were able to join us. It's going to take me just a quick second to prepare the video coming up next. Sometimes technology is not quite as fast as we would like it, but we will have it here in just a second. Okay, here we go.
Ce qui nous réunit aujourd'hui, c'est une première. Nous allons clôturer ensemble une campagne d'essai d'un moteur d'hélicoptère Safran Makila qui a tourné avec 100% de carburant durable. L'étape de ce jour, c'est une étape supplémentaire sur le chemin de la décarbonation.
Aujourd'hui, nous sommes leaders des turbines à gaz de l'hélicoptère et donc il est évident pour nous que nous devons être leaders dans le déploiement des SAF dans notre industrie.
Cette campagne d'essai, c'est un partenariat entre le groupe Safran et Total Energy. Total Energy a apporté les carburants durables.
Nous sommes autour d'un moteur standard. Il a été modifié pour permettre l'intégration des différents points de mesure. Il n'a subi aucune autre modification. Les turbines Safran Helicopter Engine sont capables de fonctionner avec un mélange jusqu'à 50% de carburant durable. Et l'objectif est bien de valider le comportement avec un carburant durable à 100%.
La stratégie de la décarbonation, elle a plusieurs piliers. Continuer d'optimiser les moteurs, l'hybride électrique et les carburants durables.
Nous sommes sur un carburant qui est issu de l'économie circulaire. Nous sommes très vigilants sur la provenance de la matière première. Nous sommes sur un procédé qui s'appelle EFA, à base d'huile de cuisson usagée et de graisses diverses et variées. Nous sommes sur un abattement de CO2 sur l'ensemble du cycle de vie qui dépasse les 80%. Nous constatons d'ores et déjà d'autres bénéfices collatéraux, une baisse très sensible du smoke number, c'est-à-dire de la fumée, une réduction au niveau du carbone et au niveau des dioxydes d'azote.
Clôturer cette campagne d'essai, c'est une étape qui fait suite à d'autres étapes. Au mois de juin, on réalisait le premier vol d'un hélicoptère de secours avec des biocarburants.
L'hélicoptère, de manière générale, est là pour aider les populations. Il est assez logique pour nous que notre contribution soit de l'accompagner avec un carburant développement durable.
Donc un chemin qui vise à aller obtenir la certification des moteurs de Safran pour leur permettre d'accueillir 100% de carburant durable.
Les deux points de vigilance que sont la mise en place des filières de production. Le deuxième challenge, c'est un coût aujourd'hui qui est assez significatif et qu'il faudra amener à des valeurs un peu plus raisonnables pour permettre un déploiement massif dans notre industrie.
Cette campagne d'essai, elle ouvre la voie à l'étape suivante, qui est d'aller obtenir un bon de vol expérimental pour poursuivre l'exploration des carburants durables en vol.
Okay, that was a wonderful video. Thought it was just going to be Frank Sato, and ended up including Jean-Baptiste, who is our next presenter. I'd like to invite him to bring on his camera and his microphone, and we will begin his presentation. And I will get your slides up here just very shortly. Thank you, Jean-Baptiste, for joining us today.
Okay, my pleasure. Well, as you've seen in the video while the slides are coming in, perhaps you've understood the vision of the decarbonization of Safran. We believe clearly our missions are highly societal, and we, as a CSR and a helicopter turbine leader, we believe it's our role basically to pave the way for the decarbonization of our industry. And you will see in the few slides how we intend to move in that direction. Done? Yeah, thank you. So our vision for the SAF, we have three pillars for decarbonization. We have the high efficiency turbine. We've been working on that for decades, and we still invest massively in that direction. We have the hybrid and more electric, of course, and we have the SAF. And we see SAF as a major pillar for decarbonization, basically because the fuel burn over the life cycle of a helicopter or an aircraft is approximately 90% of the CO2 emission over the life cycle. So this is massive, and this is why we clearly spend time and money on what is the potential of SAF and how can we support our industry to move into that directions. For those who followed the seminar last week, you've understood there are many different types of SAF, and basically each couple of process and raw material has its own CO2 impact, cost figures, volume limits, and chemical and physical properties even. We believe in drop-in SAF. This is clear for us. We understand it's not free, and we believe we must find ways to afford to go into that direction. And we also believe we will need all of them. Biofuels coming from the biomass, and also e-fuel coming from the electricity and the hydrogen, even though if that technology still needs to be further investigated, and we need also to understand the limits of it. So how we see it on the next slide, Dan, we have basically three challenges to go, and perhaps even four. The challenges we see are the technical issues, basically mainly for the turbine and the fuel system, the component behaviors, the fuel properties, and so on. As a turbine expert, we believe that we will manage to overcome all those technical challenges. This is done for up to 50% blend, and we are quite confident that in the coming years, we will be able to propose up to 100% in all our turbines. The second challenge are the upstreams, basically, so the volume issues. When we talk about volume, we must understand sustainability, optionality, and collectability. I will just mention one, which is sustainability. In that case, we need to be sure that the SAF we're going to use, basically that the cure is not worse than the disease. And typically this will eliminate most of the first generation SAF, and we have to invest massively in the second and the third generations. And the challenges associated is the cost issues. Raw material is expensive, used cooked oil is expensive, yields are everywhere in the processing, and basically we must understand that SAF will not be free. Mother Nature took 100 million years to manufacture fossil fuels. We intend to replace some of it or all of it by man-made fuel, and this has a cost. I just highlight with basically the cost of the raw material of the used cooked oil, which is basically the one we all use today. Bell and Airbus basically have mentioned they also use the same type of feedstock. And there you can see that the cost per ton of used cooked oil is already more expensive than the price per ton of the jet aid you can afford, you can buy today. So when the raw material is more expensive before being processed, of course, the end price will be significantly higher. The fourth challenge, which is ahead of us and basically is around us, is the regulations. And we must understand, and perhaps we'll also must act and be proactive, the regulations that are coming up, not only in North America and in Europe, but also very soon in Asia. The last slide for us is basically what is our big picture at Safran Helicopter Engine for that. You've understood today up to 50% SAF is a reality, and basically most of our work, and we spend a great amount of time for that, is supporting the operators. We've been the first to support the first flight with a 40% SAF last June. We have others since which happened. We have much more on the way, and there we clearly support the operators as soon as they raise their hands. That goes from technical support, that goes from supply chain, understanding the raw materials, the suppliers, the costs, the volumes, and the logistics associated, and also the regulations. We understand that most of our customers don't have basically the workforce to understand and to spend time on all of that. And so we are quite happy to share our expertise and to go along the path with them. We also apply that to us. And today our test cells in our OEM sites are running with up to 35% of blend since August. So it's in place since a couple of months. And the blend ratio will increase to 50% by 2025. We are highly invested with ISTM, and so we work the standards. And this is great because this increases our knowledge, and so we can share it afterward with our customers. And something we didn't, except in the movie, highlight yet, and this is also true for the 100% SAF, is that we are seeking the collateral benefits. And for our worlds, helicopters are quite often operated in cities. And so the local air emissions must also be covered. And so we spend sometimes in measuring the emissions associated. And we are very happy to share with you that so far we only see what we call collateral benefits with the use of SAF in terms of emissions. And what you can see on the picture on the bottom right, the black circle filter is a back-to-back test with a regular Jet A1 from fossil fuel. The right picture, you can see it's either gray when we are at MPC, but when we are on cruise, we are almost white, which means that we have quite a significant decrease in smoke numbers. And this is clearly, we see a collateral benefit for our industry. So tomorrow, the 100% SAF will allow us to go further. We have lots of projects. Some of you perhaps seen the partnership agreement we recently signed. It was announced on Monday this week with Total Energies.
We, of course, also work with other SAF suppliers that include Nestes, that include Shell, BP, LanzaJet, and so on. And so we will be very happy for the coming days, weeks, and months to share our expertise with you and to support you in your way to SAF. Thank you, Dan.
Thank you, Jean-Baptiste. Again, another fascinating presentation. I'd like to invite Doug and Stefan to go ahead and turn your cameras back on and join us. We have had a number of questions come in. I'm looking forward to running through some of them, seeing how much time we've got. I do see that some of the questions are more somewhat on the technical side, and so we may have to address those to maybe perhaps our last week's subject matter expert with AvFuel, but we'll see what we can get through today. So do appreciate it. I actually want to start with a question of my own. It was the presentations for each of the companies were fascinating. The one thing that really surprised me, I felt, was that, excuse me, I just hit my screen by accident. There we go. One of the things that surprised me was that in addition to working with SAF, each of you were also working with electric propulsion in one manner or another. And I know that we have international goals to begin using SAF within the next 5 years, 10 years, 15 years. What are your thoughts? Will electric propulsion outpace that those goals? Let's start with Doug, perhaps.
Sure, thanks, Dan. So I think that across the aviation spectrum, we'll see continued growth of electrification. But I think Stefan, in his presentation, did a really good job of trying to help explain why some of the physics for helicopters is going to be prohibitive, specifically for the power requirements that are associated with hover and things of that nature. So there may be very appropriate applications for electrification in vertical flight space, right? So I think EDAT's a really good example of that. Where it may not be the complete answer, but it may be a collaborative effort between fossil fuels and electrification, and there are several benefits to that. So yeah, I see a significant growth trajectory for electrification, but for a lot of the applications that helicopters are obviously appropriately used today, I really think that that's going to be problematic from an electrification standpoint.
Makes sense. Stefan, what are your thoughts there?
Duff said it all. I would largely concur with what you said. Then what we are doing and what we are thinking, never say never. I mean, we all know the famous quote of the 80s where somebody said, no computer will ever need more memory than 64K, So the one thing we know for sure about the future is that we don't actually know it. So as per today, we do not see that anytime soon a full electric drive could easily replace or fit the performance requirements of what I would call, a classical or conventional helicopter, and also in the missions as we know them as helicopter missions of today. Then that was fully right, and this I also confirm. There are what I would call, niche applications, and there are also areas of mission profiles where a supplementary electrical triple power can make some sense. For example, to support an auto rotation in the initial phase, just to give one example, or also in urban context. But then it is really a limited mission where you really do not want to have, local emissions. Then. But again, it's a particular mission we speak about, then electrification can make sense. If we just want to make it blunt, for helicopters as we know them, and for the missions we all call helicopter missions, we don't see that happening anytime soon. And we speak more about hybridization than really the electrification for that helicopter mission purpose.
Okay. Jean-Baptiste, I was honestly a little surprised to see that an engine manufacturer is working on electric motors. Would you like to address some of the thoughts there?
Yes and no. I believe, yes, as a propulsion system supplier, we of course work on electrification and hybridization. I had the chance, in fact, to work on the Nexus program, where we learned a lot. But basically, the slide of Stefan says it all. I mean, the cost in terms of weight and volume of electric today is prohibitive. And so as soon as you need payload and range, and in the helicopter world today, we need both payload and range, we will remain on the combination of fuel and the turbine. And so basically SAF in that direction is clearly important. What I could add, moreover, is that if we take the overall life cycle of an electric propulsion system and you compare it with a turbine system fueled with SAF, it is not obvious that you have less CO2 with the electric system.
That seems completely reasonable. Okay, well, let's jump into the SAF questions, because that's obviously why most people are here. We're getting a lot of questions about cost and availability. And perhaps, Stefan, let's start with you on this one. What are some of the biggest challenges to making SAF more readily available and more affordable in Europe? And then we'll talk with Doug on that from the US side.
Well, you know, then let's call a cat. What we see today is, I mean, we are paying a price for the SAF we are using, which is 4 to 6 times higher than the one of Jet A. So it is true. This and we are, you know, we are not naive. We are finally we need to make business, and we are also, of course, aware that our customers and operators are cost sensitive. So we are by no means denying this. However, we also need to realize and acknowledge that we are just at the very birthday of this whole journey. And you know, I think you don't need to be a genius to understand that at the very moment, with not yet a supply chain, not yet an industry really in place, that the costs are not where we all need them to be. But on the other hand, I would say, you know, there is no reason really why, you know, over some time the cost couldn't be at an affordable level. Second comment, and we heard this also last week, you know, the carbon emission. We are just fooling ourselves by not taking into account the cost of that. You know, nobody is accounting for it, but this is having an impact on our planet, and actually it should be. So, you know, then the story of the total cost would look differently. We also see the credit, you know, systems emerging, and you know, last comment there is, you know, cost is cost, but also finally, if you cannot operate anymore, you know, and if we would be living in a world which would just be prohibitive to emissions, you know, then it's a question of how else can you do, and what is primary criteria of today, which is the cost, might be secondary the day after tomorrow. So we are a bit in anticipation there, and we believe that the community, if the community really creates the demand, the supplies will pick up and costs will go down.
Okay, thank you, Doug.
Yeah, I agree with Stefan. As we see demand increase, we will see the supply and demand curve come to a bit more realistic. I would say that based on Stefan's comments, we are not seeing quite the price premium that potentially our European counterparts are seeing. But quite frankly, I think we've got to again look at it in a bit more globalistic view, and the impact, the environment, all of those things that Stefan said are right on target. We are seeing some positive signs, though, right? So from a regulation or from a regulatory standpoint, we're starting to see, at least for the blenders, you know, tax credits and financial incentives that I hope will be expanded upon and leveraged, such that that will help drive some of the demand. And again, you know, I think it was mentioned early on by one of the presentations that helicopters account for essentially 1% of the emissions for aviation. We've got to approach this not so much as a rotorcraft versus fixed craft or fixed wing issue. It's really an aviation issue, and we're all in this and have all common interests. So the better that we can drive demand for the other 99% of those aviation users that create CO2 emissions, I think we'll see with that kind of collective effort, we'll see the price equalize. It may never reach the price of a typical gallon of Jet A today. That might well not be the right goal, but I think that the benefits that it provides, the impact to the environment, all of those things, I think are readily appreciated by most of the flying public, and I believe that price premium will come to a point where it'll be readily adopted.
Okay. Let's jump. We've got a couple different questions that are dealing with the manuals. And so, Jean-Baptiste, let's start with you. We know that different companies or manufacturers are promoting the use of SAF. Governments are promoting the use of SAF. We are promoting the use of SAF. But people are wondering when they will eventually make it into the maintenance manuals and into the pilot operating manuals. Is that something you can address?
Yes, of course. It was one of the questions, and we often have that question. In fact, indeed, for what is in the manual generally is that we are always cautious with synthetic fuels because in some countries we experience, I would say, some bad habits in some occasions. And so for example, we had some case of co-factions and so on. So in the past, we've been very sensitive to that. But what's clear is that SAF are following a very, I would say, a sharp qualification process through the ASTM. We have the 7566 for the type of SAF. As I said before, there is not one SAF, but different types of SAF. And every time there is a new process raw material which is proposed by a manufacturer, there is a qualification process which often takes 3 to 4 years. It goes from theory to partial test to real test and so on. So what we are doing today at Safran, we are making sure, and almost all of our manuals are updated now, that we are clear that all the SAF which falls under the ASTM 1655, so which is basically what you can find at every airport today, all our operators can use them and fly with them. So as I said, approximately 80% of our manuals are updated now. For the other 20%, if an operators have questions, they just give us a call and we'll say, yes, you can go and fly.
Okay, well, Doug, let's address how is Bell working with that on their pilot operating handbooks?
Yeah, we're really taking our cue from the FAA and the guidance that they provided, and the global approval that they've provided has not required us to put that in our flight manual, so we haven't called it out at this point. But again, similar to what Jean-Baptiste had indicated, as our customers and partners are asking about it, we'll provide them guidance in that manner.
Okay, and Stefan?
Exactly the same. You know, being third in this row, I don't want to repeat what my predecessors said. So it's can just concur. The 50% drop in or blend, whatever we call it, it's all the same. You know, it's Jet A. Go ahead, use it. And for the 100%, there's still a way to go. It needs to be standardized, certified, and we are proceeding there.
Okay, we had a couple different questions addressing the ASTM standards, and as well as different blendings. And I think Jean-Baptiste mentioned it just a second ago, might have talked a little bit about the answer. But is there, the questions are dealing with what percentages are going to be allowed, and then the certification processes for it. So will it depend each time that they come up with a new development process to create this fuel, or is it going to be the different blends? Will they eventually reach a 100% blend when the process is sustainable to do so? Let's start with, well, let's go back to Stefan. You finished the last one briefly, so let's give you a chance on this one.
Sure.
So again, anything which has a blend less than 50% sustainable aviation fuel, so less than 50% sustainable aviation fuel is considered Jet A, Jet A1 standard. So that's why we call it drop-in fuel or some also call it blended fuel. This can be any blend below 50%. The actual blend depends, if I may say this, either on the availability or on your local dealer. We were getting 10% blends, we were getting 20% blends, we were getting up to 40% blends.
Yeah.
So this depends on the availability. Formally speaking, anything below 50% is, although it is containing sustainable aviation fuels, is and can and shall be considered Jet A, Jet A1, as it is specified and as it is standardized. So here and of course, it depends on what you want. If the higher the blend you can have, the more carbon you will reduce when using this fuel. And this blend level is just driven by the, at least as I see it, or as we see it, by the availability of the fuel. So here, it depends on the mix you want to do, and also what your dealer can provide to you.
Yeah.
Okay. Jean-Baptiste, would you like to add anything to that?
Yeah, not much. I would say what I would add is when you look at SAF, basically what your supplier will deliver is an ASTM 1655. So I have no worries, as Stefan says. If you want to go a little further, the intermediate ASTM is a 7566, which is the one for the SAF itself. And there you will see that depending the process, the percentage, the max percentage, which is authorized, can be different. The HEFA we all use today is typically up to 50%. If you want to use a SIP, synthetic isoparaffinic, the maximum blend is 10%. So basically, there is not a simple and a single answer to that. The second one for you to know, I think Stefan highlighted very well that basically the amount of CO2 you will save is based on the percentage of blend. That also relies for a small part to the type of SAF you use. So what is the type of biomass you have used before. And also for you to understand is that we are entering the world of synthetic fuel, basically man-made. So it has a price, but it has some advantages. Advantages is that we can work on the chemical and physical properties of the SAF in that occasion. And in some other ways, we are also dependent on the raw material itself. And as of today, for example, it's very difficult to find SAF above 40% blend because the quality of the SAF itself, even if it's qualified up to 50%, you need to be within the ASTM plus minus, I would say, formulas. And so there, with the raw material we have today, for example, on the market, do not expect to find a SAF which is above 35, 40%. The maximum blend we see today, 30, 35.
Yeah.
Doug, anything you'd like to add?
Yeah, there's just a couple of things. I think the first thing to remember is that it's really not the OEM or us as users that get to drive the percentage of blend. That's driven by the blenders themselves. And Jean-Baptiste mentioned it very well just a second ago, and that is it depends on what they need to blend in order to be able to satisfy the ASTM standard. And so that will vary from truckload to truckload. The important thing to note as a consumer, for those people that are listening, is that that's something you don't have to worry about, because whether you get a 25% blend of My Nesty or you get a different percentage blend of something else, really that's driven by the blenders. And the SAF fuel is tested to meet a spec for the ASTM standard at several points along the way of its production journey. So it is stringently maintained and monitored. And so while we talk about a lot of numbers for the end user, really it's just important to know that you're not going to get 100% SAF. That's not approved by the FAA today. And what you get at less than 50% is driven by the blender itself and availability. And it is regulated to the point where you don't need to remember whether you're getting a 10% blend of SAF fuel 1 or a 50% blend of SAF fuel 6. None of that's terribly important from the standpoint that it's a lot to keep track of, and it is variable. And so I think some of the things that we're talking about are great from a technical perspective, but for the end user, what they need to understand is that once it meets the ASTM spec and the fuel spec, it is the same as Jet A. And so there isn't a requirement to get worried about the percentage of blend. Just know it's not going to be more than 50% today. There's obviously initiatives that are in play that might boost that, but you talked just a little bit, and we really didn't hit on that much. There is a certification process that for anything over 50%, and as you know, you saw some of the video that John Baptiste had shown around running an engine with 100%. That's all in the test world, and at this point, that's not available to us as a flying public. At some point, it may be, but there's a lot of tests to do, whether it's effect on engine or the compatibility with fuel systems. All of those things are things that will be vetted out, and then once approved, then it will start to become public and available to the public, I should say.
Okay, all great points, gentlemen. I appreciate those responses. We are running out of time. I know it's getting very late there in Europe, and so I'm going to just wrap up with one final question for each of you. If there was one thing that your company wanted the viewers to take away from this webinar, what would that element be? What would that concept be? Let's go ahead. We started, I think, with Airbus. Let's go ahead and start with Safran. Jean-Baptiste, what would Safran want us to know, taking away from this webinar?
Well, I think from last week and today, basically, our audience is getting much more aware about SAF. I think they also understood that the industry is willing to support them. We've seen the Airbus SAF user group. We've seen the action of Bell. I think I highlighted several times that we have been supporting the operators, and we give them training. We support them in their demo or how they want to deploy. So basically, if they have to remember, I would say two things. The first one is that we said it maybe 10 times, but up to 50%, as soon as you are ASTM 1655, you have a no-brainer, you can go for it. The second one is that if you have any need of any type, your industrial is there. We all have our ways to support the user group, the direct support to operators and so on. And so we basically, the operators, they really can ask their Safran counterparts. I would say tech rep or BizDev support. Basically, they give a call if they want to know more and if they want any type of support, and we'll be there. And I believe as Airbus and Bell.
Okay. Doug, what would Bell like us to know?
Sure. So I think, first of all, I want to say thanks to everybody that's online today, right? Because what you've done is you've taken action to educate yourself around what SAF is. And there are a couple of things that I think as an operator are important to you. Number one, I think we've already mentioned the 50% blend is it, and that's important. The other that we didn't really hit on today, and that is, if I have a partial fuel load in my helicopter today, can I put SAF in it? Can I put a blend of SAF in it? And the answer is absolutely yes. So there isn't a compatibility issue around a partial fuel load with SAF. You can obviously, after you fueled with SAF, you can also fuel with normal Jet A. It's all meeting the same standard. It's all very compatible and no issues there. So if that's a question on your mind, we didn't answer it, but take that away. I really think that the thing to take away is we're in the early stages of this, and I thank everybody online for being an early adopter or potentially an early skeptic. Hopefully we've converted a few of those as well. But being an early adopter, I think really propagating the message that SAF is perfectly capable with no modification to your helicopter or your fixed wing if you operate both is really important for us, and getting people on board. It drives the demand, it drives supply, it does all that. So know that SAF is perfectly usable in your helicopter, no modifications, and find it at your nearest dealer. I guess from my perspective, that's something that we can all do, right?
Okay, thank you, Stefan.
Well, my testimony would be the following one. Helicopters are wonderful products. Helicopters do what only helicopters can do. And this is absolutely worthwhile our common effort towards a sustainable future. SAF is one element of it. There are many others. And let us all join forces to keep these products available for society and humanity for many decades to come.
That's a wonderful perspective. For everybody whose questions we did not get to, and I saw some other comments online, we will do our best to try and get responses to you offline. Please let me invite Jim Viola, our President and CEO, to come back on real quick.
All righty, very good information.
Jim, I think you join me in thanking everybody for their participation today.
Absolutely, I really do. I think it was a great discussion, great questions, and look forward to continuing. I think, you know, as everyone said, getting educated on this and getting more information. It's glad to see that our members are reaching out as well. So thank you for your time today. And thank you, Dan, for making these so successful.
Okay, well, this is a team effort. I want to thank our government affairs people, especially John Shea, who is our subject matter expert at HAI on sustainable aviation fuels. I'm going to be funneling a lot of these questions to him to try and get responses. But gentlemen, thank you so much for taking the time out of your schedules, out of your day, out of your evenings to join us, to share your knowledge and experience with the industry. We are grateful for your time and your efforts. Thank you so much.
Thanks, Dan.
And we do invite you to turn off your cameras. I've got just a few more things to wrap up here very quickly, and we'll finish the webinar. Upcoming subjects. Our webinars are usually almost always Thursday afternoons at 4 p.m. Eastern time here in the United States. Next week, obviously, migratory birds are starting to become a factor here in North America, well, Northern Hemisphere and Southern Hemisphere. They move back and forth across the equator quite often. And so bird strikes are starting to increase on both sides of the line. We want to know, what can pilots do to avoid the bird strikes, and then how to report them and why to report them? And so that's going to be a very interesting one. We've got some great people from the U.S. Department of Agriculture, the Smithsonian, from a couple of the manufacturers, even from an airport. And so I think it'll be a great discussion. October 14th, I can't pull the blanket off. It's big news. It's going to be something that HAI it's a new product we're offering, and it's going to make a big impact for the operators in the helicopter industry. And so we are going to be really excited for this announcement. The announcement will actually come a little earlier that week. But we will actually have a webinar that will discuss more about it on October 14th. So got to show up to get the news. We look forward to sharing that with you. We will be sending everybody a follow-up questionnaire very shortly. We do appreciate if you can take just a couple of minutes to give us some answers. One of the things we ask about is what webinars you'd like to see upcoming. Bird strikes actually was one that did pop up a while back, and so we started looking to see if we could put together a panel. So we do pay attention to those. We always want to know what we can do different, what we can do better. And the same with HAI in general. If we can do something for you, if we can do something better, if you'd like us to, redirect our attention. The best way to get that information out is to a direct email to Jim Viola, president at HAI. Use the email address president@rotor.org. He does see all those emails and he does send them around to our staff for tasking. That does bring our webinar to a close today. We are absolutely grateful for Doug, Stefan, and John Baptiste for joining us to share their knowledge and experience with us today. Until next week, we ask that you be safe, that you fly safe, and we'll see you next Thursday.